This is the Marta Creek, which is in the upper Maniatoto Valley, about 10 kilometres from St Bathans. And this particular site is the lake bed of a prehistoric lake called Lake Manuherikia. And this lake was around between 20 and 15 million years ago. This is the only site in New Zealand that gives us any information about the terrestrial environment between 66 million years ago and about 2 million years ago. So it's absolutely unique from that point of view. So the process that we undertake is we remove the overburden from layers that we identify as being really significant. All the clays and other soil that are on top of the particular layer that we are looking for, we call the overburden. Then once we've removed the overburden, we basically mine the particular layer that we're after. So we were mining a layer here that was only 2 or 3 millimeters thick. It got to a few centimeters in places, and we took that out in slabs. We examined it for small bones, and then we took those all the slabs that didn't have any obvious bones, and we placed those in plastic bags. We sieved some of that material in situ here, and then we spent the rest of we took the rest of it back to the museum for further analysis. But this layer could possibly represent just a single event, a flooding event, or even a drying event. And when we excavate this, we find incredibly just millions and millions of fish vertebrae. And for maybe every 10,000 fish vertebrae, we find a bird bone. For every bird bone we find, only about 1 in 20 would be preserved either one or other end, and maybe only 1 in 50 preserves the complete bone. Every trip we come down here for 1 to 2 weeks a year. We find at least one new type of bird or one new type of bat or other mammal, and on some trips we find 4 or 5 new species. So we're currently up to about 40 species of bird that we've discovered at the site, and every single trip we find bones of new animals that we hadn't known existed before. So this particular layer is near the end of the lake's existence, and perhaps that was 16 million years ago. We don't really know. It's difficult to date these sediments accurately. And it could have been a period of 5 million years after the lake formed that it took for the lake to fill up with sediment. And it's very few layers in that entire 5 million year period which actually preserve bone. Most of it's just a clay silt. Just a very, very few layers which actually have the bone. So what we infer here is that this particular layer was probably a drying event. The lake could have, even dried up completely for a very short period of time, and then very rapidly following that drying event, sticky clay came in and covered the entire bone bed, completely sealing it in for posterity. The fossil bone that we find here isn't the actual bone of the animal that died all those years ago. It's actually the chemically replaced exact impression of the bone that you find. So what's happened is that a bone has been buried under layers and layers of clay in the lake, and it has undergone this fossilization, which is a chemical replacement of the bone with minerals that look exactly, and it means that the bone looks exactly like it would have the day the animal or bird died. But then what has happened is that obviously we're no longer underneath a lake. So what's happened is all these layers have actually pushed up through the underlying bedrock due to tectonic movement. There's been a great deal of pressure undertaken, and so some of these layers are like concrete, but in fact a lot of them are still quite clayey, so it's actually not that dissimilar to what it was like when they were laid down in the lake. Imagine a scenario with a giant lake like one of the southern lakes today, like Lake Wakatipu or something like that, but even bigger. This lake was the size, or 5 times the size of Lake Taupo. It extended at its maximum all the way from the Nevis Valley south of Queenstown all the way to the Waitaki Basin. And we can imagine a series of braided rivers exactly like those that you see today, flowing down from the surrounding mountains. The landscape was very different. It was a subtropical forest. The trees were very similar to those that you find in Australia today. There are eucalypts, casuarinas, the she oaks, and many of the large-leafed plants that you'd find in the forests of northern Queensland today. It was a lot warmer throughout the year. The other thing that was very different was that the birds that actually occurred in this area were very different. So we had a bunch of ducks, which are quite different from the duck species that you see today, and you would also have a bunch of birds that no one would imagine being found in New Zealand today. For example, there was a bird like a flamingo type relative, and there were other species which are completely different from those you find today, like swifts, shorebirds, unrelated to any shorebirds that you find in New Zealand today. So it was a very, very different environment. And I also mentioned, as I mentioned before, there were 2 species of crocodile. One was nearly 3 meters long. There was a giant species of terrestrial tortoise, and there were several other animals, especially bats, that are completely unlike those that you'd see today.